Okay, here we go. Let's finish up this review from yesterday, and then we'll go to lab and you can work on study guides. Okay, so here's where we left off. One of these guys, where they're giving us a zero of a polynomial, and they're asking us to find the other zeros, find the least remaining zero and the greatest remaining zero. So how do we do that? If I'm given 1, 0, how can I find the other factor? I know that one of the factors is x plus 4. How do I find the other factor that multiplies to this? Okay, and do what? How do I do that? Wouldn't that be like this? Wouldn't that be like saying if I know that 2 times x equals 12, right? If I know that one of the factors of 12 is 2, and I want to find the other factor of 12, what did I do? To solve for x. Divide by 2. I divide by the known factor, right, to find the other factor. So aren't I just going to divide my polynomial up here by the factor x plus 4, right? Which I can do synthetically, because that's linear, right? I can do that synthetically by just plugging the 0 out in front of the bracket and running it through synthetically, right? Yeah.
Would you divide by -4 or +4?
I would. Well, I'm literally dividing by. I'm dividing this polynomial literally by the polynomial x plus 4. But what that amounts to synthetically is I'm going to put a -4 out front, because I always put the 0 of the denominator out front, which is what they're giving us, right? So we don't really even have to, I mean, we can kind of get in a habit with this. Once we get used to it, we just naturally know that when we want to eliminate one 0 and reveal the others, we just run that 0 through synthetically and take what's left over to work with, right? Okay, so let's do that. All right, so synthetically, here's our bracket. We've got out front -4. Now, what are the coefficients going to be? 29, -180. And what has to go in here? 0. It has to because of this. We know that -4 is a 0 of the function, right? So we have to just find out what the other coefficients are. Okay, so if I run this through, bring the 1 down, right? 1 times -4 is -4 plus 8. 4 times -4 is -16. That's getting big. What is that? 45? Times -4 is positive 180. What do you know? Okay, it worked. Had to. So more importantly, what did this tell us? Okay, so that's the constant. That's x. Right, that's it. So that's the other factor. That's the one that I've got to find the zeros of. The remaining zeros are going to be the zeros of that factor, that quadratic factor. So if I set that equal to 0, I've got all my Chapter 5 tricks available. I can use quadratic formula. If I can find magic numbers, that's quicker. Are there magic numbers that multiply to -45 and add to +4? There are. Say it again. 9 and -5, yeah. But we didn't have to do that. We could have also done quadratic formula. So it does factor into x plus 9 and x minus 5. And now if I find the zeros of those, when is x plus 9 equal to 0? Okay, when is x minus 5 equal to 0? 5. So those are our answers then. So the least remaining solution would have been -9. The greatest would have been +5. Okay. Make sense? Good. Okay. We have one like this. Now this, I mean, we just did this really. I guess real quick we could do this again. So, whoops. So my 0 is what? What goes out front? Say it again. Positive 2. I want the 0 of x minus 2. So x minus 2 equals 0 at positive 2. Whoops. Right? And x is positive 2. So then my coefficients would just be 3, 3, 2. Okay, whoops. Oh, what is this thing? So if we go through the process, bring down the 3, what goes there?
6.
What goes there? 4. And then what, 45? And they wanted which one? They wanted J, which is that one. It's 24.
That's all you have to do.
That's it. You're just demonstrating for me that you can do synthetic division. Okay. What about this one? When a polynomial function of least degree that has real coefficients, a leading coefficient of 1, and these zeros is written, that's a mouthful. All that's really saying is this. It's just saying what's the easiest polynomial we can build from those zeros. This is what we did in 6-7. So what do we do with those zeros? What's the factor that goes with the 0 minus 4? 4. Well, not 4. X plus 4. What's the factor that goes with... There we go. So we just build the factors associated with the zeros and multiply them. And that's it. So that's all it amounts to. Now, there is a little bit of strategy involved here. Can anybody tell me which two of those, to make this easiest, should I FOIL out first? Yeah, the conjugates, right? Because when I FOIL out conjugates, I'm going to get my x squared minus 4x plus 4x. So the x terms cancel, and I just get a minus 16. And now I can expand those, and I'm done. So x first times first is x cubed. Outside is minus 3x squared. Inside minus 16x, and last plus 48. Done. Make sense? And then last one. Oh, actually, there's one more. There's one more on here. Real quick one. Just look at it and tell me the answer. How about that? That polynomial has at most how many real solutions? 5. Yeah, 5 because, yeah, the degree of the polynomial is 5. So we know it has 5 complex solutions. And then the imaginary ones come in pairs. So I could either have 0 or 2 or 4 imaginaries, which would leave me with 5 or 3 or 1 reals, right? So 5 would be the most. Okay, so this guy, last one. So we wanted to use finite differences to determine the degree of the polynomial. Now, on the graphing calculator part of the test and review, I'll actually have you tell me what the polynomial is, but here I just want to know what the degree is, right? So, how do we do this again? If I've got data where the x's are increasing, well, no, not for this one I don't. If I just want the degree of the polynomial, okay, good. I'm just going to make that difference tree. So negative 3 minus negative 1 is negative 2, because I'm adding. If I subtract a negative, I'm adding, right?
Yeah.
Negative 3 minus negative 3, those cancel, right? What about this one? 2. Okay, we can see that it's going to work next time, isn't it? Okay, so it took how many times? 1, 2. So it's second degree. Right? Okay.
Fair enough.
It looks like they're eating
That's the last problem.
oh yeah. It looks like they're eating the negative 2 to 0 to 2 to 6.
That's right.
Now 9.